Welcome again. So look at what moving to what product of vectors. In product of vectors, before now we have seen how addition of vectors developed naturally for the problem of what combining displacement. And we are going to use that vector addition for calculating many other what vector quantities. Are you getting me? So when you hear of vectors, they are not ordinary numbers. I said that when I started introducing in what vectors. Okay, 2 plus 3. I know it's 5. That one is the scalar. But in terms of vector, we don't add like that 2 plus 3 is 5. No. That one can only happen when they are in what? Towards in direction. So vectors are not ordinary numbers. So ordinary multiplication is not directly applicable to what? Vectors. Just ordinary multiplication does not just apply to vectors. So we are going to look at two different kinds of product of what? Vectors. We are going to look at two. And the first we'll be looking at what is what? The scalar product. Scalar products. We're going to look at the scalar products. Look at the scalar products. And and scalar products use what? A result that is what? That is what? That is a scalar quantity. And the second we'll look at what is what? Vector products. And vectors will yield a what? Yield what? Another what? Vector. So scalar products yield scalar quantity, while vector products yield what? Vector. So now we dive into what? Scalar what? Scalar products. So scalar products of vectors. What are we looking at here? So scalar product of two vectors. Let's assume we have two vectors here, vector A and vector what? B. It can be in any direction. It could be in any form. You can have something like this. This is B and this is A. Can also be like this. Here could be A. Here could be B. And here is our 5. It could be any of this. So the scalar product of two vectors A and B is denoted as this, and is also known as what? Dot product. And that name for scalar product is also known as what? Dot product. Are you getting me? Though both of them, this is vector, but whatever you have in this dot product is not a vector. Whatever you have, the quantity you have after simplifying, working on this, is a scalar. I hope I'm not that fast. Whatever you have after this, what? Applying dot product to two vector. You apply dot product to two vectors. What you have is a scalar, no longer a what? A vector. Are you with me? So to define the scalar products A, vector A dot vector B, after drawing these two stuff, you can see now their tails are at the same point. Their tails are at the same what point. The angle phi is a Greek. This angle is a Greek is a Greek letter phi, and between their directions ranges from 0 to what? 180. This phi ranges from 0, 180, 0, sorry, 0 when they are what? Parallel. 180 when they are what? Opposite in direction. 0 when they are pointing towards the same direction, 180 when they are what? Directly opposite in what? Direction. So, what can we really say about this? Here, vector B is toward the direction of vector A. Vector B is toward the direction of what? Vector A. While here, vector A is toward the direction of what? Vector B. In the component vectors, I told the guy that angle to the what? To horizontal. Toward the direction of vector B toward the direction of vector A, and vector A toward the direction of what? Vector B. And going back to component of vectors, we are going to bring in few things here. You can study those component of vectors, those addition of vectors I did, and I'm going to marry in some things here because that's why I started from from the foundation level, and I'm coming up. So what can we really say about this? Here now, I can say B to the direction of A. Vector B to that direction of A is what? B cos phi. B to the direction of A is this, while A to the direction of B is cos A cos phi. So, having this in mind, vector A dot vector B is now what? Vector A in scalar now. Now this A, then this guy, B cos phi. Or you can present like this: the magnitude of A, magnitude of B cos phi. I hope I'm not fast. Let me repeat this again. Here, vector B is the direction of vector A, while here, vector A is the direction of vector B. So taking this guy now, I can say vector B is same as what? B cos phi. Go back to component vector horizontal, we use cos theta. I hope you do understand. We don't use what? Cos theta. Now, this now, we are not solving using vector now. We use scalar because this is scalar product. So, the dot product of vector A and vector B is the magnitude of A multiplied by what? Magnitude of B cos what? Phi. This phi is the angle between vector A and vector B. Angle between vector A and what? Vector B. So this is definition of what? Scalar. What another name for scalar? Dot product. Scalar or what? Call it dot product is still what? The same thing. So if I'm to represent this other one, oh, if I'm to represent, if I'm okay, in this one I have B, then A cos A cos phi. So calm yourself down. When you really observe this, what can we really see? This is same as what? AB cos phi, or write it like this: vector A, vector B cos phi. So let's look at it gently and see what we can pick out from here. The scalar product is a scalar quantity, not a vector. Scalar product is a scalar quantity. So this is scalar quantity. Whatever you have here is not a vector. Take note of that. And it may be what? Positive, negative, or zero, depending on the value of our what? Angle. It can be positive, negative, or what? Zero. You know, when the angle is between 0 to 9, 0 to when the angle is less than 90, when it's less than 90, we have positive. When it's at 90, you should know, of course, 90 is what? Zero. So what it means now that if it's at 90 degree, the dot product of these vectors is what? Zero. And once it's greater than 90, but less than 180, we're going to have what? A negative value. So when phi is between 0 to 90, what does that mean? When what I'm trying to say is this. I hope you are following. I know you are following. When cos phi is greater than what? Greater than what? Zero. And the once when this is greater than zero, once it's greater than zero, and our value here is positive, and our value here is what? Positive. What it means is that phi is between what? Is between 0 and 90 degree. So if phi is less than 0, equals phi is less than 0, what it means is that this guy is between what? 90 degree and what? 180 degree. So you should be expecting something what? Negative. Are you getting me? Should expect something what? Negative. The scalar product of two perpendicular vectors is what? Is always 0. Either perpendicular, angle between them is 90 degree. The scalar product of this is 0. I hope you are taking note of what I'm saying. So for any two vectors, vector A and vector B, from what I have done so far, for any two vectors, vector A and vector B, AB cos phi is same as BA cos phi. What does it mean? Vector A dot vector B is same as what? Vector B dot what? Vector what? A. Is commutative. Is commutative. Is commutative. So take I say when they're in the same direction, that means when they're in the same direction, but when phi is 0, when phi equals to 0, are you getting me? When phi equals to 0, A dot B is equals to what? A B or A B. Know that cos 0 is same as what? 1. So let's look at moving to what? Calculations regarding what? Scalar product using what? Components. Using what? Components. So we can calculate scalar products A, vector A and the vector B directly if we know the what? The x, y, and z components of what? A, B. So, and already you know that I dot I is same as what? J dot what? J and same as what? K dot K. Are you getting me? Remember when I started unit vector, I said the unit of this unit vector is just one, is unit. Are you getting me? So it's taken as what? 1 by 1. Discover that they're in the same direction. But into the same direction, this is what? Cos 0, which is cos to what? 1. Ij equals to I k equals to j k equals to 1 times 1. That's the unit vectors. These are perpendicular to each other. Cos 90 degree. This will give us 0. This will give you 0. So, what does this now mean? What does this now mean? It means that vector A, B, I'm taking my time to move slowly so that we all will be on the same page. Vector AP, same as what? AXI plus AYJ plus AZK plus BXI plus BYJ plus BZK. Under unit vectors, I fully explain this. I fully explain this. So now from this point, what can we do next? We can go ahead. Sorry, this product is does this does this. So with the knowledge of opening of brackets, with knowledge of opening of brackets, how do we go with this? This is same as you just need to be careful. Okay, I'm to the A's and AS. Okay, as with me. So this you multiply this now. now to the last one. Okay, that is that we have. That is that we have. So what can we see here? What you can see here now is, hope is covered. Yes, okay. What you can see here, this is same as what? AX BX I dot AX BX I dot I plus AX BY I dot J. Now this will give you what? 0. I dot J 0. AX BZ I dot K. I dot K. This also will give us what? 0 plus AY BX I of I. So yes, there should be a mistake here. I use this to multiply 1, 2, 3. So this is supposed to be J. 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 Okay. The first line, this multiply each of these three. Second line, this multiply each of these three. Third line, this multiplied each of these three. Okay, sorry. Here is J. So we have I dot J here. Here also is 0. Now move here. Plus AY BY J dot J. And this also give us 1. Then this next plus AY BZ J dot K. This will give us 0. Come down here. I need to be careful. AZ BX K dot I. K dot I is 0. J and K is 0. What's K? AZBX, Abi. I move here. AZBY K dot J. You already know that here will give us what? 0 plus AZBZ KK. You know that KK is 1. So it's covered. Okay, I think it has gone down. Okay. With this, let me bring the video down. Sorry. Okay, with this, I can say that vector A dot vector B is same as this is 1. So I have what? AXBX. Since I dot I is just 1 plus AYBY plus what? AZBZ. K dot K is 1. So scalar product in terms of what? This is scalar product in terms of component. So if we would just have X and Y components, we'll stop here. But here we're looking at X, Y, and Z components. That's why I went ahead and proceed to this point. So at this junction, let's look at the question. You can pause the video at interval and solve as I solve, so that we all learn together. We all grow together. Okay, let's look at it. We say find the scalar product. Find the what? Scalar product. Find scalar product. Vector A or vector B of two vectors. Of what? Two vectors. In figure below, the magnitudes of the vectors are what? 4.00 and B is what? 5.00. Where the diagram is what we have there. Covered. Okay, it's covered. So here we have what? 15.0 from here to here. 5. Then from here to here is what? 130 degree. This vector B, vector B. So this is the question we have. This is our I, this is our J. This is question we have. I say what? We find what? The magnitude of the what? Of the vectors. So it depends on the formula that you want to use. You can straightforward just write it. Go ahead. Vector A, vector B, A, B cos phi. Yeah, phi is going to be what? 130 degree minus 53 degree, which give us 77 degree. So vector A dot vector B is 4 times 5. 4 times 5 cos 77 degree. You can use a calculator. You can compute it in your calculator and you will have the value, but okay, should give around 4.5, right? 4.50. Is there any other way? Can we also solve it? Is there any second method we can use to solve this? Yes. 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 This is the first method. Recall that this is the same thing as saying ax bx plus what? Ay b what? Y. Ax bx. Since there is no what? Z. There is no z. So just and then there is z. I'll proceed and add what? Az plus what? B what? Z. So we have two formulas. I gave you guys vector A dot vector B equals what? A B cos phi or ax bx plus ay by plus az bz. So now see x-axis. This is the y. This is the y. X-axis is horizontal, and y-axis is to the what? Vertical. So ax bx. What's our ax? Take note under components of vectors. Horizontal is what? Cosine. Our a is 4. As will be what? 4 cos what? Or angle horizontal? 53 multiplied by what? Bx. B to the horizontal. B to the what? Horizontal. And here now, horizontally B is to the negative. I explain this, which is what? B is what? 5. No, the negative side, that is minus 5. Cos what? If here is 130, or let's just leave it 5 cos 130. Yes, to see bring out our negative. To see give out our negative plus ay sine 4 sine 53 5 sine 130. So if you compute this with your calculator, 4 cos 53 will give you approximately 2.407. I've already solved it. So 5 cos 130 will give you minus, I got minus 3.214 plus 4 sine 53 give us 3.195. Then 5 sine 130. What am I get? 3 points. Sorry, okay. 3 point what does I have there? 830. By the time you simplify this with your calculator, you'll be having what? 4.5. Having 4.5. This gives us, by the time you simplify your calculator, you'll be having 4.5. So that is that regarding what? Scalar products. That is that regarding what? Scalar product. Let's see another question. Here, says you find the angle. Find the angle between what? Between two vectors. Vector A is what? And vector B. How did angle come in here? Before now, I've said that this is the same thing as what? AB cos phi, and this is the same as what? AX BX plus AY BY plus AZ BZ. What does it mean? It means that this also, since this is equal to this and this same thing is equal to this, that means this is also this equals, or this equals this. So I can write AB cos phi equals what? AX BX plus AY BY plus AZ BZ. So making cos phi the subject of the formula give us cos phi plus what? Everything about what? AB. This is just what we need to get our answer. That is just what we need to get what? Our answer. So there is nothing much there we will be what? Looking at, will be doing. It's just as simple as that. So from here, what can we say? We can see that our AX, okay, let me define our parameters. Okay, solution. My AX is 2, AY is 3, AZ is what? 1. Right? So the components of what? Vector A. So that component of vector A. So let's go to what? Component of what? Vector B. In vector B, Bx, you know, say it minus 4. By is what? 2. And Bz is what? Minus what? Minus 1. And that you have what? Also what? Seen. That you have also what? Seen. So, taking note of this, short of space, close, okay. So taking note of this, so now I can now write that's AX BX plus AY BY. Hope I'm not too fast. At this junction, so my AX is what? 2. BX is what? Minus 4. Hope you're with me. Plus AY is what? 3. by is 2, az is 1, bz is minus 1. You can see that, right? Minus 8, hope it's captured. Okay, it should. Minus 8 plus 6 minus 1. Minus 8 plus 6 minus 1 give us what? Minus 3. So give us what? Minus 3. So this gave us minus 3. So the next part now is for us to get A. A now is what? 2 square plus 3 square plus 1 square. Square root of what? 9. That should be 14. That is 14. Then B is what? Minus 4 all squared, 2 squared, minus 1 squared. This is 16 plus 4, 20. That's 121. And it's 21. I hope you understand this. A is a point. A, some of you may ask me why is it? We just find the resultant. Why do you find the resultant? Please pardon me. A is a point. In X, it moved by 2. In Y, covers 3. And in Z, covers 1. So getting the resultant is what gave us this. B also minus, okay, started here, 4 negative 2, this minus 1. So getting what? The resultant. That's why we'll go ahead. Then, before I start solving this, I wrote something on the board that cos phi simple as ax bx plus ay by plus az bz over ab, right? And this gave us what? Minus 3. A is root 14 multiplied by root 21. This is what we have, and in a calculator, we compute this in calculator. This will give you minus 0.175. Now get the cos inverse of minus 0.175. But when it is minus, we say our angle is between what? 90 and 180. I explained that when I started scalar product. Angle is between 90 and what? 180. So what are we going to impute between 90 and 180 that will give us what? Cos. So cos inverse of 0.175 is approximately 80. It's approximately 80. So getting 80 in the second quadrant, it gives us what? 100 degree. It's only cos 100, that's the angle between 90 and 180, cos 100. That will give you this value, minus 0.175. I think for now we'll stop here in scalar products. Now next video we'll touch what? Vector products or cross products. Take note, another name for scalar product is what? Dot. dot products. We'll stop here so that the video will not be too lengthy. If you have a question, let me know. I welcome every comment, every challenge. We learn together, we grow together. And let's help this channel also to grow. Thank you.